ratio is going to be my new variable, and I'm going to divide cranial capacity, which is what I'm really interested in, but because it's contaminated by body size, I want to control that. So I'm going to divide it by my body size t-score variable, right? So everyone's got a body size t-score variable. People who score high on this have large body size, and people who score low have relatively low body size. So it's going to control for that. At least that's what people think it does. So I'm going to click OK. So I've created a cranial ratio variable, so people who have higher scores score a higher relative cranial capacity given their body size. Okay? And people would say, okay, now I'm going to do my analysis of variance on this new ratio variable that's controlling for body size. So I'm going to go into one way, and it's already there because I've done the analysis. So I'm going to put sex into factor, and I'm going to put my cranial ratio variable into the dependent list, and I'm going to click OK. Actually, you know what I'm going to do? I'm actually going to do the analysis of both of them. Even though I've done it before, I'm going to put my cranial capacity and cranial ratio. Okay? So in the cranial capacity, I've got males having larger cubic centimeters, 1473, and females 1270. I've already done that. I already know that. But that's contaminated by body size. And that's why I did the analysis of covariance and found different results. The adjusted means were different. And now I've got my cranial ratio variable. And now females are actually scoring higher than males. So this is not what you would expect. And this is a very, very different result that I'm going to get in my ANOVA analysis. So in the first ANOVA, which just is dealing just with cranial capacity, I got an F of 50.91, which was statistically significant, suggesting that males have larger cranial capacities than females. But then when I do the cranial ratio variable, I get a statistically significant effect again, F37.17, significance of p less than 0.001, but females have a higher mean than males do. So this is radically different results, suggesting that when you control for the body size composite variable, that females have larger cranial capacities than males. But this is wrong, and what I'll suggest that you do is look at some papers that have analyzed ratio variables and argued that there are some very strict assumptions under which it might work. And one of them is that's very important, is that the regression of the dependent variable and the covariate that you're interested in actually go through the origin. That means that they have an intercept of 0. That just doesn't happen in practice. And there are also some other assumptions that the numerator and the denominator won't correlate with each other. I should say that the ratio and the numerator aren't going to correlate with each other. Anyway, if you want to learn more details about how bad ratios are at being analyzed, you type into Google Scholar analysis of covariance alternative, and you'll get a paper called Analysis of Covariance, an Alternative to Nutritional Indices. Now, obviously, this is very specific to nutrition, this journal, but the principles apply to every data. Data don't know where they come from. So it doesn't matter whether you're analyzing finance data, physiology, neuroscience, it doesn't matter. Ratios have the same limitations applied to them no matter what discipline. And so I've shown here in this tutorial or this video demonstration that analyzing ratios is just probably the worst thing you could ever possibly do in data analysis when you're trying to control for another variable. Please don't do it. But I think what's also interesting about this is that you can analyze data in at least superficially appropriate ways and get very different results. And people argue that with statistics you can make statistics say anything, and I don't think that's true. But I do think you can analyze data in inappropriate ways and come to inappropriate conclusions. But the average person would have no idea that it is an inappropriate way of analyzing the data. I think that's probably a better way of saying what statistics can do, is that we have a lot of opportunities to analyze the data in different ways and trick people. Yes, that can happen. But if you know a lot about data analysis, then you know when you're being tricked or not. And I suspect the reason why people use ratios or residualized ANOVA is actually so that they can publish significant research. I think in some cases they don't know what they're doing, but in other cases they do, and they're just doing it to get the results that they want to get. So the buyer has to beware. Thanks for listening.